Okay, speed run again. This is the second fun sheet. It's the same week, but we're computing limits, limit laws. I'm gonna skip over this because I know it, and hopefully you know it. The five limit. Okay, evaluate the following limits. Lim g of x. So if g of x approaches a, g of x. Okay, wait. The limit for g of x as x approaches a is 10, and that. That's how you say it. So evaluate the following limits. Well, as g of x, as x approaches a, g of x is what, 10, and then f of x is 2. So this is 5, and then we could say the same thing here. 5 times h of x as x approaches a is negative 4, plus g of x as x approaches a, which is 10. So we'd say negative 20 plus 10, that is equal to negative 10 probably. Jesus, my handwriting is really bad on MS Paint. Direct substitution. So here, we're literally just plugging it in. So negative 6 squared, which is negative 36. I think something that trips up people here is it's not negative x squared, it's negative x squared. You square it and then it's negative something something PEMDAS. So minus 36 plus 20, I want to say that's 16 negative, and this thing is negative 1. This is a odd degree, so that's just negative 1 plus 2 minus 15. I'm not doing that. You guys can do that. F of x does not have to be a polynomial in order to use direct substitution. Yo, do I need to plug all these in? Oh. Like, honestly, is this just Desmos work? This might just be Desmos work. So if we have, like, f of x, f of t, sorry. Dude, I'm not doing that for all of them. Okay. Negative 2 to the 4 minus 6, that's 10. And we divide that by 2 times 4 minus, well, plus 6 plus 2, 0.625. What is that actually though? 16. So what is that, like, wait, what is the top one then? 10 over 16. Yeah, it's 10 over 16. We do the same thing here. What is, that's just 1 minus 3 plus 3 square root of 1, which is 1, right? I hope so. Is it? 1 plus, well, 1 minus 3 is minus 2 plus, yeah, okay. This one is funky because I'm pretty sure if we have 2 times negative 4, that's negative 8, so 8 minus, negative 8 plus 8, that's 0. So we have 16 plus, well, minus 4 minus 12 is 0, which means this thing, as x approaches negative 4, if we direct substitute, is 0 over 0. We can't do that because it's undefined. You can't divide stuff by 0. You can't divide anything by 0. Something something math prison. So does it tell us what to do here? It does. Try to simplify by factoring or simplify that. Right, so literally use the same thing again. Well, how do we factor this? We could say x squared plus x minus 12 is, let me mental math factor this. We could say, how do I clear this? Right. X squared plus x minus 12. What factors 3 and 4? One of them's going to be positive, negative to add to 1. That's 4, negative 3. X plus 4, x minus 3. And we could rewrite the top as 2 times x plus 4. Right, so what we actually have is 2 over x plus 4 over x plus 4 x minus 3. This cancels out, so we're left with, this is kind of like 2 over x minus 3, and we can evaluate this limit instead. So as x approaches negative 4, we can directly substitute, because it's no longer indeterminate, minus 4 minus 3, that is equal to 2 over negative 7. Yay. So let's do that for here. Yo, I do not remember how to something expand squares. Wait, expand, what was it? It was like, we can say x cubed plus a cubed is equal to, let's say, like x plus a times x squared minus 2a, what is it, minus 2ax plus a? Is that true? I should just Google it. Wait. Expand cubic. Yo. What? Wait. Sum of cubes. Okay, I was close. I was close. A plus b, a squared minus ab squared. Okay. So knowing that, we could rewrite this as, what is it? We have x cubed plus 27, or maybe 3 to the 3, so that is x plus 3, x squared minus 3x plus 9. Yay. Which means, rather than x plus 3 over x cubed plus 27, we have x plus 3 over x plus 3, x squared minus 3x plus 9. This cancels out, so we have 1 over x squared minus 3x plus 9. We could, I think, directly substitute this, right? Minus 3, so we have 1 over 9 minus, well, not minus 9, it would be plus 9, because negative 3 times negative 3 is plus 9 equals to 1 over 81. That's probably correct. Do I fact check? Do I fact check? I'm gonna go with my gut on that one. I feel like I shouldn't be making these videos with so little confidence. Hold up. X plus 3 over x to the 3 plus 7 approaches negative 3. Like, I'm like pretty sure I'm correct. Am I? Maybe I'm not. Wait, did I mess up somewhere? Wait, no, 81. It's 27. I don't know how to add. Yeah, it's 1 over 27. Oops. X squared minus 25. Okay, awesome. Well, if we just cut, we could rewrite x squared minus 25. Well, that's equal to x plus 5, x minus 5, difference of squares, and then 2x squared plus 11x plus 5. So we're gonna have to do some factoring here. We know one of our factors is a 2x, and then the other is an x, and then our constants are 5 and 1. We'd want to 2 times 5, and then just 1x. So 2x squared, 10x, plus 1x, so that's 11x, and then plus 5. Yay, vector. So this one will cancel out one of these. So we have x. This one cancels out this one. This is on top. Now, x minus 5 over 2x plus 1. We can directly substitute negative 5 now. So we have negative 10 over negative 5. So negative 10 minus 9. I kind of regret doing these now. I thought it'd be a little more fun, but but they are fun. They're fun sheets. And then these two negatives cancel out, so it's probably 10-9. Maybe I should have the cheat sheet pulled up. Oh, this one's crazy here. So we can't really just factor it because it's not really a polynomial. So what do? Well, maybe I should write the problem out first. So obviously we can't just plug in 0 because then it's 1 over 0, 2 over 0. That's weird. So we should just multiply by x over x. This is like the same thing as multiplying by 1, so it's equivalent. We have 1 minus 3x over 2 plus 4x. We can directly substitute 0 now, so it's 1 over 2. Yay. Oh, this one is kind of gross as well. Let's see if I remember how to do this one. Cut. So we have 5 over 8 minus h minus 5 over 8 over h. When you see two of these guys together with the denominator, your first instinct should be to get a common denominator. So we're just gonna like cross multiply this. We have 40 over 8 times 8 minus h. Because basically what we're doing is we're doing like 5 over 8 minus h times 8 over 8 to keep it the same. 5 over 8 times 8 minus h over da 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 da. And then this is subtracted by 5 times 8 minus h over 8 over 8 minus h. By the way, I haven't been doing this. Oh shoot, I forgot my limit notation. Ah! Do I put it in now haphazardly? Sure, why not? So the limit as h approaches 0. This is a terrible video. Over h. So these have the same denominator now. We can combine these, and honestly, I'm just gonna like distribute this now. We have 40 minus 40 minus, well, actually it's plus because this is a negative, plus 5h over something something limit notation. Yo, why am I doing this in MS Paint? We have this over 64 minus 8h, and then this is all divided by h. And this gets rid of that. And then now we could move this back up here. We can multiply this denominator by this denominator. So what we have is 5h over h times 64 minus 8h. This h cancels out this h. This is 5 over 64 minus 8h. Hey, we could substitute in h as 0 as h approaches 0. Yo. This is equal to 5 over 64. Probably. Right? I don't see why not. I don't think I did anything wrong. Watch me record all these videos, send it to Debbie, and then Debbie finds like 20 things wrong. Maybe maybe every time a student points out something wrong in these videos, they get an extra point on their test. What else? Is there more? There is more. It's probably correct. Maybe I'll look over the video later, and then if I have to, I'll redo it. Oh my god. Cut. Cut. Limits involving radicals may be solved by rationalizing. Yeah, okay, that makes sense. So as this approaches 1, then we should... Okay, so how do we approach this problem? If you see a problem where it's like a radical plus something like a constant, you need to do something called multiply by the conjugate. The conjugate is basically like this, but the opposite sign for the second term. The reason why this works is because if you remember difference of squares, x squared minus, well, actually, that's a bad example. A squared minus b squared is equal to a plus b, a minus b. So we could say that x minus like a squared is equal to square root of x like plus a square root x minus a. That's why it works. So a really funny way of explaining it. So we're just gonna multiply this by the conjugate of the bottom, square root x plus 1 square root x plus 1. Since we know the difference of squares magic, we can just say like, oh, the middle term cancels out, so we just need to worry about these guys. This ends up being x minus 1 square root x plus 1 over what is it? X minus 1. And then you see here, this term cancels out this one. So we're left with the, oh my god, I keep forgetting the limit. You know what? Debbie, you can yell at me later. I'm just not gonna put the limit definition. Yeah. We're just left with the limit as x approaches 1 of square root x plus 1. Like, I probably would do it if this was pen and paper, which I will later. Maybe. Square root x plus 1, and then that's just, it's 2, right? Square root of 1 plus 1 is 2. Yay! I mean, I'm pretty sure that's what that limit evaluates to, because we did this, right? Okay, that looks right. Maybe I should have shown me foiling it to prove this, but if you see this, then this is this and that. Yeah. Okay. What is it? Cut. Let's solve this one. Square root of x plus 4 minus 2 over x as x approaches 0. So as this goes to 0, this is square root 4 minus 2. 2 minus 2 is 0 over 0. Technically, you can El Hopital this, but you don't know that yet. So how do we deal with this one? Well, we use the same thing. We something conjugate, except this one's a little bit grosser. We'll do x plus 4 plus 2 square root of x plus 4 plus 2. What does that mean for us? Well, that means this is now x plus 4 minus 2 squared, so 4. Let's just ignore that. Also limit x approaches 0. Okay, yay. X times square root x plus 4 plus 2. These x's cancel out, so it's just 1 over square root x plus 4 plus 2. As x approaches 0, we have square root of 4, 1 over square root of 4 plus 2. That's equal to 1 over 4. 2 plus 2 is 4. the limit as x approaches 0 for square root x plus 4 minus 2 over x is 1 over 4. Ah. For piecewise... This is a 7-sheet fun sheet? Yo. Okay. Uh, piecewise functions. Nice. May be found by first finding the one-sided limits at the point. Find the limit for the following function at the given points. X approaches 0. First finding the one-sided limit at that point. Dude. Like if we plug these all in, 2x minus 4 at 0 is negative 4. X squared of 0 is 0. And then 3x minus 2. Well, that's not even like... Okay, let's actually just draw this thing out. So while x is negative, or on this side, we follow this. 2x minus 4. What, negative 4? Right. Oh. So it's like coming in from like here, isn't it? Like all the negative, yeah. So like it would just be like, oh, that's not very good. I should probably start from the start, like that. It's not supposed to be that curvy, but it's okay. And then x squared for x is equal, greater than or equal to 0, less than 2. So like let's just say this is 2. This goes up here until like, let's say like 4. And then 3x minus 2. Okay. So what is... That's... Okay, and then like it just kind of goes linear like that because x of 2 is what? 4? 3x. So 3 times 2 is 6 minus 2. That's 4. So this photograph looks like... It's weird, but it works. So the limit at 0 just doesn't exist. That's just too freaky. As it approaches 2 from both sides, it goes to 4. Maybe I should write this out. So A is D and E, they don't kiss. B is 4, because these two piecewise things meet at the same place. And as it approaches 5, we would literally just plug it in here, like 5. So what is that? 3 times 5 minus 2, 15 minus 2 is 13, right? I don't know. Okay. The limit of f of x as x approaches a can always be found by direct substitution if the value a is in the domain of f of x. Find the domain of each function, write your answer using interval notation. Well, we know, because we're in Calc 1 and we only care about real numbers and stuff like that, there's two things to consider. We cannot divide by 0, and we cannot take the square root of a negative number, or like we don't want to. So how does that factor in here? Here, 1 over x minus 4. In interval notation, we can take it from any number from like negative infinity to 4, exclusive union 4 to infinity, exclusive, because you know we'll never actually reach infinity, but it's like, yeah. For the square root of x squared minus 5x, we need to make sure x squared minus 5x is greater than or equal to 0. Or I guess in math it'd be this. So x squared is greater than or equal to 5x. And then if we divide by x, x is greater than or equal to 5. Does that check out? That checks out. Because if we had like 1 minus 5, that'd be negative. So 2 times 2, like 2 squared is 4 minus 10. So, yeah, x is greater than or equal to 5, right? Well, hmm, 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 hmm. Hold up. What am I thinking? Nah, I won't think about it. I won't. Actually, now I need to think about it. Uh, is it really just that? There has to be another one where is it the absolute value? Is there two inequalities here? There is because it's a quadratic. So, hold up. We have to think about this as x over x squared. Oh my. X minus 5 is greater than or equal to 0. And x is equal to 0 when x is 0. Duh. And x is 5. So x has to be greater than or equal to 5. But x has to be less than or equal to um that's a good question, chat. Less than or equal to 0, right? Because if it's like yeah, less than or equal to 0, because once it starts becoming negative, we have like negative 1 squared, so it's just 1 minus 5 times negative 1, so plus 5. Okay, so it has to be less than or equal to 0. So our domain is from negative infinity to 0 inclusive, probably, union 5 to infinity exclusive, probably. That one probably shouldn't have taken as long, but whatever. This one looks really gross. Wait. Okay, let's think about the domain here. So we have square root x, that cannot be less than 0. So x has to be greater than or equal to 0. And then we have the bottom, we can't let that be 0. So we need to factor that out. We know that one of our factors is 3x, the other is x, and then our constants be negative 1 and 1. I want to say this is positive 1 and this is negative 1 because 3 minus 1 is positive 2. That should factor out, yeah. So now we solve for when this equals 0. 0 when x equals negative 1. X is equal to 1/3. So this gets covered by that. So really what we need to say is from 0 to 1, well, not even 0 exclusive, right? If it's, yeah, it's from 0 to 1/3, not inclusive, and from 1/3 to infinity, we can have valid x values. This is a trick one because it's a odd degree root. I forgot what it's called. The cube root. It's odd, so we can actually have negative stuff in there if I'm remembering correctly. So we could just say this is like all real numbers. I forgot how they write it. Right? If I type that into a calculator and there's like some funky stuff going on, I'm gonna get really sad. But that should like always have. I'm pretty sure that should be all real numbers. We could just say like from negative infinity to infinity. And is that the entire sheet? Hey, that's the entire sheet. I'll move on to the next one. Yay.